So for wind analysis, I'm using Eddy, and this plugin, along with the plugin itself, you have to install something known as CFD, which BlueCFD, which I think I hope you've already installed. Coming to the model, uh, for right now, to keep things simple, I just have the isolated model. If you have the site or some buildings around, we can hide it, and make sure that if it's lofted, it's sort of capped, so there is nothing at the top. And I mean, there's no sort of an empty hole at the top or at the bottom. And I also have a rectangle, and we'll get to this in a bit, that why do we need this rectangle. And I mean, we will be changing the rectangle, but more on that later. Now, when I have uploaded this code, and this script has multiple options, let's see what this script demands and what's happening. First thing is just feeding the actual building mesh. Now this could be multiple meshes, so they'll join at the end, but I'll be feeding just one mesh or one brep, one polysurface, which is this. This is the size of the mesh, which I'm not going to get into. The size of the mesh is 10 meter into 10 meter. That is one size, is 10 meter into 10 meter. Second thing is this, which is the wind direction. 0, you will realize, is one direction, and then it goes from, what I have said is wind direction 0 from 0 to 360. So you can have wind whichever direction you want to simulate or visualize the wind in. Then you have the domain box. The domain box covers the geometry, the terrain. We're not looking at the terrain or the site right now. We're just looking at this building in isolation. And these boundary conditions, which basically take the wind direction and also the wind speed. I'm just taking wind speed as 5 meter. I'm not changing this right now, 5 meter per second. And it also takes these three numbers, which we'll see in a bit, is actually a domain box, which under which all the calculations happen, right? So it just gathers that whole domain box. Then it takes into simulation. Simulation does two things. First is a button that you'll have to run the mesh. That means what it does is it takes the domain box and it takes the building mesh, and then it creates sort of a, imagine a series of numbers. It just readies all these numbers that can go into the wind calculations. And then it actually runs the simulation. It does the calculations. This is where it might take from 5 to 10 to 15 minutes on your computer, depending on the complexity of the model. This is where all the calculations start working. Now comes this part, and this is very important. Just by doing calculations, you're not able to kind of extract data. Do you want pressure? Do you want speed? Where do you want to see that? So you need points, and that's why we have something known as a probing part here. That means, okay, we have the whole box, which has all these different values of different properties like pressure, like wind speed, but where do you want to extract these data from? So you need points, and for that we will talk that why I need points in this particular arbitrary height, and this is where I want to see the wind. And then it goes into visualization, which just shows the arrows of the direction. So quickly, if I go back, I will first feed this here, select one brep, and I'll select this. Okay, now you'll see you'll see one arrow here, which is the direction of the wind. This is 0, but I can always change it, and this is where you can have whatever direction you want, right? And this is the size of the box. Keep it higher than the height of your building, just enough for the height of your building, and big enough so that my probing rectangle, which is this, is contained within the box. Okay, and then finally I'll have this curve, which I'll select this, and it will populate 3D. This is a Rhino thing, so that I have these points, and these are the points. I can increase the number of points as well, but the more the points, denser data, and it might not be very accurate. Let's see, we'll get to that in a bit. But first, let me run my simulation. Everything is done. I have to run the mesh first. So I'll run the mesh, and it's going to take some time. Now my mesh has been run. I'll go into this button, which is run simulation, and it's going to take a good amount of time. It might take anywhere from 2 minutes to maybe 15-20 minutes. Okay, now for me it took 4 minutes to do the analysis, and since the simulation is done, we need to extract some points, and the points are coming here. Before I proceed, I just want to tell you that if you look at this particular component, it's listed here in Eddy under setup. I'll just quickly run through where all the components are located. This is all Grasshopper standard. This is located here in Eddy under ABL flow. ABL means atmospheric boundary layer. This is domain box, again located here. You can have a box shaped domain or cylindrical domain. I'm taking a box shaped domain. Then this is running settings. Run settings are here. Mesh settings we're not playing with, but run settings are here. Then this simulation. Simulation is under setup, and if this code shows error, that is because it will borrow my directory into your system. So it says C do users Mayank Eddy. You might have a different name. So I will advise you that if this doesn't work, you can go to setup and borrow simulation, and then connect everything. These are buttons, standard Grasshopper buttons, and connect our settings to our settings. Then finally, we have population 2D is a standard Grasshopper population component. Probing, there are two probing components, and both are here. One looks like an X, which is this, which takes the building mesh and takes the points, and one feeds it into the results, which is this eye symbol that you see here. That takes the points, that takes the results of the simulation, and that takes a button. One last thing is it says that please provide a unique name, otherwise a new instance will override the results. That's okay. And it says that does not exist, please run the probing component. So this standard button we'll have to use to run this. We have taken the points here. I can take the points later also wherever I want. I can take the points at 90 degree also. For example, if I want to see wind in elevation or in section, where is the wind going? But for now, we're just going to take it in plan at some random level, and make sure that your this curve is within the domain box, right? It's almost there. Yeah. Now I'll have to run this, and it might take some time, but you can see the wind already. I'll hide everything. Control Q or right click preview. I'll hide this as well, and you can see the probing component. You can see the wind sort of going around, and you can see this is a low pressure area, these are high pressure areas, and kind of, you know, this thing is happening. You can also have different numbers. I can take 200, run the probing component once again, and have more points. I can also try to rotate this at 90 degrees like we did, and you can see we run the probing component. Now this might not be accurate, sometimes it creates a problem, but you can see that the wind sort of starts going around. That is because our wind direction is that way, so it doesn't make sense that it's the vertical plane is not, so it's not really accurate. But I can come back, I can run this again, and I'll see this beautiful visualization. You can have it more points, but sometimes it shows errors. 500 points. Yeah, nice. And it shows a very nice colored thing. You can also, here with the visualization, you can change the size or the thickness of these arrows. I can also hide this, and it's pretty solid. You can try this with one model, you can try this with multiple 2-3 models. If this shows any errors, which it might, let me know. But this screenshot kind of works. And yeah, this is for one direction. This is for wind from this direction. You can always change that. If you change the wind direction, you'll have to run the mesh again, run the simulation again, and then run the probing once again. So that's all. I'll just have one last look, and you can take a screenshot, and this works.